Therefore, let's get started. Okay. Now, with air conditioning, we first need to define what is air conditioning. What is the purpose? Air conditioning is, it cleans, cools, and dries the air. And we're going to be referring to this as I talk about other things regarding air conditioning. What I mean by that is, when we talk about the humidity factor, for example, this week here in Las Vegas, we're going to hit probably by Saturday, they're saying 115 to 118, but that is mostly a dry heat. But due to the population growth, humidity levels are rising here, so the dry heat is not so dry. And then in August timeframe, we get the monsoon season. So therefore, people will tend to say, hey, my AC, I have to set it cooler or colder, whether being at home, whether being in an office building, whether being in a vehicle. The AC does tend to work harder when there's more humidity in the air. So therefore, your specifications, and I'll show you some examples later on about what kind of temperatures should I see, especially in high humidity. What temperatures are you going to see when there is, in other words, high humidity? So therefore, humidity does play a role, and that's why we say it dries the air. So therefore, it does clean. Today's systems nowadays now have cabin air filters, so that's a new thing. But in the past, we didn't have a cabin air filter on a lot of trucks. So therefore, the cabin air filter has added insurance policy to protect any contamination, dirt, or even smells that can come about with the evaporator, which we'll discuss later on as well. So when you talk about people complaining about AC, there's many issues. What are those issues? Well, the AC just doesn't work. That's the common complaint we get when trucks come in, not cooling, somewhat cooling. In other words, lukewarm, as people like to say, or maybe it's just not blowing in the face. There's no air coming across into the face. So your job, as we'll talk about the initial diagnostics of AC, is you want to go ahead and check to see if all the modes are working from defrost to face to floor. Are we seeing that we are getting airflow going in there, and maybe making sure we have adequate airflow as well? And in this case, the compressor cycling excessively. In this case, we got a compressor cycles on, cycles off, cycles on, cycles off. And in this case, it could be a good example of either high pressure or most likely low pressure, meaning it's got a low charge. And then the bottom, you can also have a hot air where we actually have a motor stuck in the hot position, and that could happen too as well. So now obviously our training is going to be about air conditioned refrigeration system here used with 134A and 1234YF. But in this case, we're not going to talk too much about the heating system, but we will mention and talk about some of the issues going on there. So as I move along again, chat or go ahead and unmute your microphone or hit the chat button if you have any questions as we move along. So if you've been working with AC systems, let's say you're doing a cab off repair, you're doing various other things, or maybe you're just trying to fix the AC system, you got to know your refrigeration system and how to do the job right. I'm going to leave you with one thing. I'm going to start off with one thing, excuse me, as I go ahead and talk about refrigeration systems and AC systems. And that is this. If you look at let's say I buy a brand new truck. What is the life that I expect out of that AC system before it'll need to be opened up or need to be serviced? Now, if there's mechanical problems with the engine, that's a different story. But the thing is, what I'm trying to say is when the vehicle comes new, what is the average life of an AC system? For example, my '06, I've never opened my '06 system on my '06 F350. So therefore, my AC system on my '06 F350 now has what? It's an '06, it's 2023 now, so therefore what, 17 years? So in this case, we're talking about that's how long my AC system has worked or is working on my '06 F350, believe it or not. So we have I guess what I'm trying to say is the life of an AC system is dependent, especially on pressures and proper maintenance if it's done correctly. So therefore, AC systems can live a long time if done correctly. Here in my home, I'm actually talking to you from my home office, and my home actually has got that rooftop AC system sitting on the roof. So that poor thing sits on the roof and it's sky high. And I have literally understood and trained myself on some home systems because again, I had every AC guy that came out here wanted to replace the unit, and in this case, I'm still running with the same unit. I've done a lot of repairs to it, but in this case, it's the house was built in '99. So it tells you how old my AC system is. So therefore, again, proper care and maintenance, you'd be surprised how long an AC system works, even in the worst of environments that I live into as well. So you got to know it. What are the types of systems? As you can see here, there is two basic types of refrigeration systems. There's going to be variances between, I understand, but I had to generalize it. And in this case, it's thermostatic expansion valve or orifice tube system. Those are the basic two different types of refrigeration systems. Now, with ongoing technology, we're going to see a few changes with controls and so on, but it still comes down mostly to thermostatic expansion valve or orifice tube itself. So therefore, that's what we have to know. Now, I also understand that we have the different refrigerants. There is the 1234YF, which we'll discuss later, along with the 134A refrigeration system. So, in order to understand how it all works, you got to know the components. And I think most of you know the components, but I'm going to mention them anyways, which is the compressor, which many people will say is the heart of the system because that is the circulation tool that actually moves the refrigerant. There's the dryer, the accumulator, so therefore there's receiver dryers on thermostatic expansion valve systems, and then there's the accumulator that's used on orifice tube systems. Names may vary depending on manufacturers, but basically that's what we see there. We have a condenser, we have the fan clutch or a viscous fan clutch. So therefore, like on going back to my Ford F-350, I do have a viscous fan clutch, which is PCM or ECM controlled. And then you got the mechanical fan clutches like some of the earlier Duramaxes that actually have literally a fan clutch, which we'll discuss here in a sec. But in this case, airflow, right off the bat, airflow is critical for proper AC. So when I deal with RVers, for example, like to put a motorcycle or bicycle or obstruct the front of that vehicle, it does impede on airflow. So therefore, airflow can't say enough both on the condenser side and then on the evaporator. So therefore, on the evaporator, we have the blower fan as well. So in this case, the blower motor needs to be blowing adequate air. And one of the tests we'll talk about later on when we go into the electrical aspect of AC is again diagnosis of the blower motor because we have seen cases in older trucks especially where the blower motor was turning the opposite direction and that was creating not enough airflow. But then we have our controls, and boy, have the controls changed. If I look at a brand new 22, 23 truck, everything now is pretty much all digital display, all push button on the display. And in this case, the controls have changed. But it is still a module that communicates within the network, and that network will have actuators that have inputs. And those inputs could be switches, relays, and also the high pressure input along with a low pressure input if so equipped. And then you got also codes, body codes that actually can be set. So therefore, those body codes also will pretty much be something you can look at. In other words, you can scan issues, not only a body, because a lot of us are pretty much, used to using the scan tool for drivability, transmission, ABS, but you also have some body controls that you control too as well. So in this case, please know there's got to be something that controls the unit itself. Excuse me. So with that said, please note that there are controls for these systems there. Now, the gauges is pretty much where everybody struggles at. I don't know where you guys are at in terms of your level, but we'll ask that later on as we move ahead. But again, your gauges are pretty much the main, telltale of what's going on with the refrigeration system. But this is under the understanding that you have good adequate airflow going across the evaporator and good flow going across the condenser. So AC diagnosis relies heavily not only on feel, but also using your gauges. They are varied amount of gauges used, but it comes down to your high pressure side and your low pressure side of what's going on with AC. So therefore, you can interpret a lot and you can understand a lot by looking at the pressures, but we're going to give you some charts that are available. And I did a search when I was finishing up this side of the presentation, and I couldn't believe so much information out there that you now can readily have. I went through my boxes recently and I found some old AC books, and a lot of it now is online. Just a matter of doing a Google search, and you'd be surprised what you might find when it comes to pressure. So, but we need to break down the AC system into the two departments. What are those two departments? Well, there's a refrigeration side that I've been mentioning already, whether it being 134A or 1234YF. Now, the system develops the cold. This is the cold that you need to cool, clean, and dry the air. So therefore, that's a refrigerating side. And then we have the HVAC side, which HVAC stands for heating, ventilation, and air conditioning. That is the whole plastic housing that sits underneath the dash or behind the bulkhead of the truck, or whether being on a rear AC system too as well. So the airflow that is diverted to your face, the seat position, whether being the seated face position, you're going to the floor, or you're going to the defrost mode. It all depends how it's all set up. Because let's face it, we use air conditioning, believe it or not, in fairly cold environments because we're using the dry air to actually dry that windshield or that moisture that can be condensing into the windshield or the windows of the truck. So the blower motor develops the airflow to go across the evaporator, and at that point is diverted to a combination of different modes. Again, floor and face to defrost and face. It could all vary depending what model truck you have. So your job is to verify are all the modes working. So as you diagnose an AC system, you'd be surprised at all the different AC system and problems that I get. Number one is, it's just not cold. Okay, but is there airflow going across the face? Is there some of it leaking up to the defrost, some of it leaking down to the floor? In other words, you need to verify that it's all working. Am I getting hot? Am I getting cold? In other words, that mode temperature door. That also needs to be checked because maybe it could be stuck too. So you got to verify that. So the first step, I mean, we're going to be talking about different technical items, but the first step in diagnosing AC performance is to follow a procedure, what you're going to do. Obviously, the easy ones, like I said already, is it's not blowing cold. I know. But you need to check the whole operation of the AC system. So visually, you want to set the face-to-face mode. They want you to a temperature check too as well, but we're going to not get too hard there yet. But in this case, your job is to turn the AC on. Let's go ahead and put the blower on high. Let's make sure we got adequate airflow. Again, no leaks to the defrost, no leaks to the bottom, but you may want to cycle the different modes, right? Now, at that point, let's say the air is lukewarm. Okay, you probably got a refrigeration problem, but you still need to verify that you do have adequate airflow and you're not leaking in other modes. So therefore, am I looking at a refrigeration problem, at an HVAC problem, or both? So therefore, the customer might have been living with, it leaking to the defrost mode a lot in the face as well. So therefore, they were just not aware of it or didn't care. That could have been the issue too as well. So there are other vehicle models that have more than one fan in the engine compartment. So your job also is to verify adequate airflow. So as you open the hood and you check your AC, if it's got electric fans, you need to make sure those are chucking air or moving air. If it's got a dual air system, depending what model it is, maybe there is a low speed and a high speed fan, varying speed fans. You need to make sure that they're working adequately. And I don't need to tell you that with the scan tool, you can control them too as well, those fans on many different applications like GM applications too as well. So therefore, make sure that you got adequate air at the fan. But we got to keep something in mind though. Can't have no obstruction. So since we live in the desert here, we actually get a lot of dust. So therefore, there's a lot of stuff that accumulate between the radiator and that condenser. Maybe there's a charge air cooler too as well and other coolers. So therefore, we got to make sure we have no obstructions of airflow too as well. Now, I know what you're thinking. Some of you might be using your temperature gun to look at the inlet outlet. We'll get to that. But in this case, the basics, what I'm trying to say is, do we have adequate airflow across the condenser? And do we also have good blower motor volume coming out? Because at that point, we can also investigate to see if there is a dirty cabin air filter, if so, equipped on the truck. So make sure you check that. Cabin air filters, very important to do. So, I have a Toyota Tundra, and before I left on vacation last week, I decided to check the cabin air filter. And boy, I was amazed at how much, even though I felt I had good airflow, just by removing the cabin air filter and putting a new one on, I was amazed how the airflow just increased even more. So yeah, we were freezing in that truck, and it's a black truck. So yeah, I know, stupid me buying a black truck, but there you go. So let's first talk about the fan clutch style. Now, I get a lot of issues. The Ram trucks for the longest time has had problems. The 5.9s, early 6.7s, those diesels. We have had nothing but problems in the past and continue, actually. I should say we still see them from time to time. We see problems with the fan clutch itself. So here's my question. How do you test a mechanical fan clutch, as you can see here, or a viscous fan clutch? How do you test it? Many people will go ahead and put a pretty much something or a blanket or some fender covers in front of the grill, and they try to restrict the airflow. So therefore, that bimetal spring in that clutch assembly right there's a bimetal spring, will actually control a hydraulic coupler, if you will. And at that point, what it does is that it releases or engages. So therefore, as it gets hot, the bimetal should open, the valve should move, the hydraulics inside of it or the fluid moves, locks it up, and you should hear the roar, right? That's very common to do. If you have scan tool control and it's an electronically viscous fan clutch, then at that point you can command the fan clutch like on any Ford Power Stroke from 6.0, 6.4, and 6.7, you can do that. But here's the question though, with a Power Stroke, you have the ability to watch the fan speed on the scan tool. So you go ahead and select fan SS, which is the fan speed. You can control it with the bidirectional controls. You can see the fan speed change and you audibly will hear the fan roar. That's fine and dandy. But let's go back to the mechanical ones, not computer controlled. We like to do what we call the paper towel or paper test. Okay. What we just simply do is we put, you know, a paper towel or, piece of paper in front of that, whatever's in the front. Usually charger cooler, like on a Ram, is the one that's outermost towards the front. We put it, and that paper should always stay on there. If you actually idle the truck, because where we see issues is that the fan might be cooling above idle speed. So if the guy's sitting at a stop for a long time, let's say he's at a signal light, he misses the signal light, he's still stuck in traffic, he's been there now for 10 minutes, you're going to see the temperature rise on that truck. And in this case, as soon as you take off, you get the green light. What happens? It cools down. So therefore, you can even hear the fan roaring. You're like, oh, it's not the fan clutch. Why is it running so hot? And you think you got issues. Well, these 5.9s and 6.7s, some of you may know this already, actually are notorious for not providing adequate airflow at low speeds. So on a 5.967, the scan tool does have bidirectional control, believe it or not, of the fan clutch, but the stupidity of it, yes, I said this, the stupidity of it is that you can't control it while the engine is running. So what good does that do to me? So therefore, what I'm trying to say is you actually need to do the paper test or the paper towel test. Just put it across as the engine is idling. If it ever drops it, then therefore you got no air coming in flow, especially at prolonged idle periods. And that's what actually causes it. Now, since there's inadequate airflow, you got to remember at this point that the pressures in the refrigeration system are going up and up and up and up, and that's where you heard a compressor. So during the summertime, I'm sure we just hit finally high heat. I'm sure I'm going to see a few trucks this season through August, September. I'm going to see compressors all locked up. The question is, what took out the compressor? High pressures. But why did you have high pressures? Because you didn't have adequate airflow going across the condenser because of the fan clutch itself. So I challenge you, next time you look at a 5.9 or 6.7, especially before 09, 10 models, that's very common, but we still do it on later models too. You may want to go ahead and put a paper towel and let her get hot and see if it actually drops the paper or the paper towel, whatever you want to do. So therefore, I like to use a sheet of paper. So therefore, just put it up there, and at that point, you see if it ever drops it. If it does, again, you got a fan clutch. Now here's the kicker: I have had bad fan clutches, and I order a new one, whether it be from the dealer or from the local auto parts. And guess what? I put it on, and I still do, even on a brand new one. The Dodge dealer, the Ram Dodge dealership, they were ticked off at me because I sent 3 of them back because they would not work properly. Finally, on the 4th one, it did work properly. So even the new ones to the day, even last year, I had a few that were bad. So all I'm trying to say is verify the operation of the new fan clutch. So therefore, I see it both in the aftermarket and even OE. You're thinking OE is the better one. That's what I thought too. No, it's not actually it. So that actually contributes to the life of the compressor because again, adequate airflow across the condensers reduces the high side pressures, and at that point it helps the compressor live a longer time. So therefore, airflow going across is very critical. Okay. Now, I already talked about the cabin air filter. I told you about that too. Again, we told you about checking the modes of the blower, make sure that the blower is blowing. So if you look at an older model, let me first talk older and I'll talk later because they have different setups. For example, the blower motor could have a blower motor resistor, or it could have a blower motor module, or it could have a body control module controlling, actually 3. So in this case, one of the things you can do that I'll talk about when we talk about session 2 of this AC is putting an amp clamp on the power wire going to the blower motor if you have access to it. A lot of them you do have access, some don't, but you can actually do that. And you're going to measure the amperage draw of that blower motor to see if it's not pulling too much. In other words, it's looking at its last days, or it actually is turning in reverse. That has been known to happen. And by the way, for those of you never seen this, if the blower cage is turning reverse order, it'll still blow some air, but not adequate airflow. So therefore, it's not good. So therefore, doing an amp test is going to tell you a whole heck of a lot. Not to mention, it'll tell you if there's restrictions on the suction side of the blower motor too. So we'll talk more about that later as I get into that. So therefore, verify all the motors. Now, it is number 5 says there that it is common to see vacuum control mode. Some of you know this already, some of you don't, depending, I don't know where your experience is at. We all know that there's many trucks out there, especially the early years, that were using vacuum controlled motors. And if you lose vacuum, the default has been for the most models has been it actually shoots air to the defrost mode. In other words, up to the dash. So when we get a truck that comes in and definitely has all the air going to the top, that actually tells us that most likely we got a vacuum line disconnected and we got to see where the vacuum line has been disconnected at. So in this case, you can actually verify that. So therefore, there are trucks that are equipped with vacuum pumps. And in this case, gasoline trucks will also use vacuum from the engine itself. So therefore, that's on gasoline applications. But please note that every time when a truck comes in and it's always shooting to the defrost mode and it's got vacuum control actuators, then therefore it's definitely most likely a cause of loss of vacuum. But we need to make sure we got no vacuum leaks. Now, as we look at various different applications, they're all going to vary. I mean, when you look at an old Silverado pickup, a Ford pickup, you look at a Ram pickup, you're going to see different modes of operation. So therefore, as we look here, let me go ahead and select the highlighter here. So in this case, as we look at a highlighter, we're going to see different things, but we're going to see our main components right here. As a matter of fact, let me move this over. What do we got right here? Well, we got an evaporator core. So therefore, there's our evaporator core. There's our blower motor. So obviously the outside air comes in. So therefore, as the outside air comes in, we're going to see that it goes across the blower motor, then across the evaporator. So therefore, if you really look at airflow right here, you're going to see that the blower motor blows air across the evaporator motor, and then there's your blend door right there. So therefore, when I look at my blend door right there, that one's going to control my temperature, and you're going to see your heater core as well. So therefore, you're going to notice that all airflow that's coming in this model actually is going across the evaporator, whether the AC is turned on or not. So therefore, that's why we see non-cabin air filter equipped trucks will actually get a lot of trash, a lot of crap in there because of the fact that it's just bringing in whatever's outside. So if there's a lot of dust, leaves, and so it isn't surprising that the evaporator actually will get a lot of junk on it, which eventually will need replacement. There are cleaners you can try to use, but haven't had too much success only for odor control because mildew in high humidity areas can actually accumulate around there. But then, like I said, we got our heater core right there. So therefore, there's the heater core where we actually have the coolant actually being circulated through here, and that could heat up that incoming air. So can you have heater on and air conditioning refrigeration going through the heater core? Yes, because like we said already, that will dry the air going towards the heater. That's when we see fairly cold, not cold, cold, but semi-cold, where the compressor will still kick on, and at that point, that will dry the air, which we can send up to the defrost mode, which we see up here too as well. So in this case, what I'm trying to say is that, it is a good idea on those trucks that are not equipped with a cabin air filter to always stick a camera. Some guys, if accessible, is some are very easy to remove the blower motor from the bottom of the dash or maybe from the side of the front, depending how it's all set up. And in this case, this allows me to go ahead and put a camera in there. If I can't see, I can do a camera view of what that inlet of that evaporator might be looking like. So therefore, I definitely want to verify that because just because you don't have adequate airflow, it doesn't mean it's a bad blower motor either. It could also be that the evaporator is actually just extremely trashed up, very contaminated. And it's kind of sad because, like on an '06 truck that I did, I told the customer, listen, I took pictures of it with my borescope and showed the customer, it's just so much crap on there. And the truck only had 80,000 miles. And literally we had to charge all the labor to pull the whole dash out to get that to get to that evaporator. So that was not fun. He didn't like it, but hey, that's what he needed to get his air conditioning back up. So definitely those of you that live in high humidity conditions, like I said, mildew and growth can grow there. And there's different cleaners they sell. You can spray in there. You might have to drill a hole that you can eventually silicone into the housing. But what you're going to do is you're actually going to clean up that and pretty much, you know, what you're trying to do is just get rid of odor, any growth, of bacterial growth that can get people sick too as well. So some people might say when I turn my AC on, I start sneezing, I get sick, I blah blah blah. It could be that the evaporator is just really contaminated and has got growth in there. So therefore, be aware of that. So therefore, yeah, that's what we see there. And on this bottom assembly, oops, sorry, on this bottom assembly here, you can see again there's the blower motor right here, and in this case, we see the blower motor. Where am I at? Right there. So therefore, there's your blower motor, and there's your temperature blend door. There's your heater, and then there's your evaporator, and that's your outside recirculating blend door. So therefore, how's this all working here? Well, let's see. The blower motor is located here. This is your outside air, inside air on the bottom. So therefore, it can vary in design as you can see here. So therefore, it all depends on design. Okay. So therefore, just understand the location of the blower motor and the location of different components. Now, I don't know if you guys take time to look in the service manual, and there's a lot of explanation on how the airflow works on different service applications, which I'll discuss at our part 3 and going over service information too as well, what's available for you. So now, when you're checking your AC, it is important to make sure that the truck does not have a heater control valve. For example, 6 liters. Here's a good example. That's the one that everybody can see there on the passenger side, sitting on the top. It is a vacuum controlled heater control valve. Actually, I don't know if this is the actual one. I took a picture of one. But in this case, oh yeah, it is vacuum controlled. This is a vacuum. Duh. So in this case, we can see the diaphragm right there. That's going to move put it over here. That's the vacuum control diaphragm right there. And in this case, we could see that the vacuum control is going to move this lever and control the flow of coolant going towards the heater core. Now, why do we actually cut off, the coolant going to the heater core? Because we don't want that intensity of heat sitting in that HVAC housing. So therefore, we just shut off coolant flow to it. So therefore, the HVAC housing can stay cooler with the evaporator, with the refrigerant going through it. So that's something we need to verify too as well. Now, many trucks, you won't see much of a difference in refrigeration control. In other words, the coldness of it, but it affects to a certain degree. So therefore, you want to make sure that you actually verify that that is in the closed position, but also verify its operation. You could put a vacuum pump, make sure it's not binding. And obviously, they can leak coolant too as well, but just verify that it is closed during AC operation. That is something you always want to look at. And I got to tell you, when we get a lot of 6 liters, since I mentioned in this, I can't tell you how many of the hose just is falling off. It's just sitting there falling off and it's never been working right. So you want to verify again that that heater control valve is indeed closed and that's what you're looking for. But when you look at refrigerant itself, okay, pressure is pretty much, I would like to say, is everything. So therefore, the first thing in order of business is that the challenge is the system contaminated? So when I go to my local auto parts store, or I look on Amazon, you see all the stuff that's being sold. People have been topping off their refrigeration systems till finally it doesn't work. Every year I got to put a pound in it or this and that kind of thing. The problem is some of those refrigeration cans that they buy can have oil in it, right? Or they got some other stuff or dye in it. So therefore, dye, oils, or other refrigerants have been used, which can contaminate the system. Now, when I visit our outfit here in Las Vegas called Auto Air and More, Auto Air and More, they repair a lot of AC machines. They repair machines. And I asked them a while back, a few years ago, I said, what do you guys find that you're fixing on AC machines or station recovery stations that you do? And a lot of them is contamination. They get a lot of contaminated machines, meaning that excessive dye, excessive other refrigerants, other stuff that's in it. So therefore, that is a big problem when we're dealing with some trucks, especially since I'm in Las Vegas. We get a lot of out of state trucks. What do they put in it? So it is a good idea to get an identifier. So a lot of guys don't use it. My identifier, I got to get a new one that's no longer working. I just tried to use it the other day and it doesn't work too well. So therefore, that's another thing. And what is another contaminant that people can say it's a contaminant is air. So therefore, we shouldn't have any air in the refrigeration system. So, we're supposed to suck down the system, make sure it's in a vacuum, and then fill it properly. But many people don't realize they're also pumping in air there too. So as well, especially they have a leak too as well. So therefore, again, pressures are going to be affected dramatically by a non, approved refrigerant that's being used, like R40, 22. So therefore, you got to watch out for that stuff. And then the other thing we have to check for is there could be excessive moisture there. So therefore, it could freeze up internally because there is water turning into ice, if you will. So therefore, moisture can be a problem there. So I know that the accumulator dryer and the receiver dryer are designed to, again, to have a desiccant bag in there to dry it. But in this case, it could get overwhelmed. So therefore, you guys in high humidity areas, you will have this as a problem. So your job is to make sure we have a dried system. Not to mention when you buy a brand new receiver dryer or accumulator, don't open it up to the humidity. As soon as you install it, then you take the caps off and you install it because you want to make sure that you have not that much moisture absorbed by that desiccant bag that's inside of it that's absorbing that moisture. You don't want to overwhelm it already. So therefore, you're not sure. You don't know what's going on, but again, you need to make sure that you have the refrigerant you're supposed to have. Now, the price of 134A, I just called yesterday the local auto parts here, and it is the latest price that I got was 279 for a 30-pound container. And 1234YF, oh my God, that is mega money. We're talking about over for that kind of container. I believe it's $900. I forgot. I gotta look. I didn't ask him about that one, but when I called a while back, it's very expensive. So, 1234YF is significantly more expensive than 134A. So therefore, yeah, I understand that. But again, you have to have some kind of identifier. So here's one that I'm looking at purchasing right here. And this is the Master Cool 69134A refrigerant identifier. You want to know if you have excess air. You want to know if you have any non-approved, not a 134A, but you can also get one for 1234YF. A lot of people haven't been messing too much with 1234YF, but in this case, this is designed for 134A identification. So you may want to take interest because you may want to test to see what kind or is there contamination in that AC system. And why do you do it also too? Is to protect that refrigerant that's already in your recovery machine. So therefore, you don't want to contaminate your recovery machine. Because imagine if you have the wrong refrigerant in there and you got it mixed with 134A, are you going to get optimum temperatures once you charge the system up? Nope. So therefore, you definitely want to look at getting an identifier. I myself, like I said, I got to get a new identifier myself too as well. So therefore, something to keep in mind because you definitely want to make sure that you have again the 134, 1234YF, and no other contaminant. So the charged refrigerant, the status of the AC system you're working on. So the thing is, you're approaching this vehicle. You just did an initial diagnostic, like we've said in the previous slide. You verified the airflows, face, defrost, floor. You check to see there's good airflow across the evaporator. You tested the blower motor. If I got a refrigerant problem though now, you know, is the AC too much? Is it too charged? Has got too much of it? Too low? Too much oil? The popular one that I see is oil. Oh God, a lot of oil. Too much oil in the system actually will affect it. Too much air, right? There could be air. And like we said already, there is too much moisture as well. So this is the twos, too much of everything. So in this case, we need to verify that. And I'll tell you some strategies that I take to make sure we test it. Because if the customer, I'll try to get some information. Mr. Customer, have you actually tried to charge it yourself? Did you put one of those bottles, those little bottles they sell that you can charge your AC system on the low side? Did you put some of it? Does it have any oil? Do you know? Blah, blah, blah. So I don't know if the system's charged. So when I do an AC service or diagnosis, I charge for the recovery and the charging because I need to know where we're at. There's no way of me knowing what's going on the outside, so it could be overcharged or undercharged. So your AC recovery machine is going to be your best friend, but we'll talk later on more about the recovery machine. But in this case, I hope you have maintained it. You change that oil, especially on that vacuum pump. You've changed your filters inside of it. That's all needed for proper operation of the machine. So there is maintenance that needs to be done with the machine. But in this case, we need to recover. When you're looking at a system and you need to know what's going on, maybe it's the pressure all over the place. We got to understand that we don't know, again, that there is too much oil, too much air, or too much refrigerant, or too low, right? So therefore, the best idea is to actually recover. Now, a lot of your recovery machines have the ability to extract the oil. They separate the oil. So in this case, we have PAG oils out there. We got minerals, we got ester oils, and so on. So in this case, what I'm trying to say is we got to make sure we have an understanding of how much oil there is. For example, if I recover the refrigerant off of a vehicle that I'm diagnosing, and it's done with the recovery, and then it shows me I have a little bottle like this model right here on the far right has a little bottle way over here, and I could see right here, how much oil has actually been retrieved. So if it all of a sudden pulls 4 ounces, I'm going, oh my God, that's a lot of oil it pulled out of that refrigerant. So therefore, that's telling me that most likely I got a lot of oil in the system. So therefore, since I recovered, my next course of action, if it's an orifice tube system, for example, I will take the accumulator off and I'll drain it to see if it's got excess oil too as well. So if I pull 4 ounces from the recovery and I pull another 3 ounces from the accumulator, that system is vastly overcharged. So therefore, you got to know how much oil the system takes, which we'll get to in a second. So in this case, yeah, I use this not only to recover, but also to determine how much oil there might be in the system. Now, there's no way of me knowing if it's a PAG oil mixed with ester oils or some other mineral oils that are not supposed to be there. I understand that. So therefore, we just got to assume that that oil is the approved oils. Now, the oil fiasco has changed. Now, we used to have so many PAGs. There's still quite a few variations, but not as many as there were back in the day when 134A was coming out. So therefore, yeah, we don't know what PAG oil or what ester oils are being used. So therefore, like it says on the bottom bullet, the course of action needed is to ensure you have some pressure on the low and high pressure gauge. So therefore, when you initially, before you recover, you connect the machine, you're going to go ahead and look at the pressure. So if they're both at zero, most likely your system is empty. But guess what? I'm going to do a recovery even if it takes a few minutes. We're going to see what comes out of there, if anything. But it might be low. So if you see 10 psi on both the high side and low side, yeah, you're running low. So therefore, you still recover, you still want to see, and then at that point you can decide what's going on, whether being you got too much oil, too little oil. But I'll try to make sense of it as we move along. So like I'm saying, is you taking a quick look at your gauge readings, the low and high pressure side. Yes, there is a low and high pressure sides in an AC system. I haven't introduced that, but yeah, there is a low side, which we tend to be blue, and then we got a high pressure side, which we tend to use red color to show that example there. So therefore, let's mention peaks. What are the peaks? For the peaks on an operating system, if before I recover, let's say it is kicking on, let's say it is working, I generally don't want to see no more than 50 psi. And again, no less than 15 psi, you know. And then on the high pressure side, you got to make sure the compressor is engaged, obviously. And in this case, the magic number that should scare you is 400 psi. If immediately I turn an AC and if I see that high side gauge jump to 400, if not more, then that's a red flag right off the bat. Whoa, we got too much pressure. So as we introduce AC, obviously we got to go in more details. I'm just throwing you some basics here. If you hit 400, that is a big red flag right off the bat. Therefore that is a scary situation for the AC system. So therefore, high side no more than 400. While the low side, you don't want to go over 50, and in this case, obviously no less than 15 psi. So therefore, under 15, depending on the calibration of the low pressure switches, it could cut out the compressor at around 20 or cut it out at 15, depending on the make and model that we're talking about. So therefore, I know that you're looking at those readings and you want to try to make sense. Hold on. We'll continue talking about it as we move on ahead. So the AC recovery process, you gotta, this is under the assumption the machine is working good. You're gonna go ahead and pull the refrigerant, anything that's in the system, it's gonna pull it out of it. So that's why again, we use the identifier, we pull everything out, and like we said already, it'll actually separate the oil to tell you roughly, it'll tell you what the oil content was in that recovered refrigerant. So again, we're gonna look at some numbers, and like I said, 2 ounces is probably the max, but in this case, we'll talk more in detail about it. But yeah, we should not see that much oil coming out with the refrigerant. But here's the other thing. If you pull refrigerant out of recovery machine and you go ahead and pull out so many ounces, you should put some of that oil back in if it's a normal machine there, so a normal system. So therefore, as much as we take out, we also need to put it back in if necessary. So therefore, definitely want to keep that in mind because a lot of guys recover when they're doing repairs and they're taking out oil. They're taking out oil because the oil itself, like for example, let me backtrack to R12. I know this is not an R12 class, but in this case, R12, the old diachlorofluoromethane stuff, the R12, the mineral oil went into solution. So therefore, as the refrigerant was circulating through the system, it was carrying the mineral oil with it. However, with 134A, with PAG oil, it is snotty. It's just snotting down there. So we used to have back in the old days, in our community college days, we used to have a plastic see-through accumulator, and you could see the refrigerant and the PAG oil actually circulating, and this PAG oil was just snotty. So therefore, it's kind of like snot moving throughout the whole lines through the whole system. That's the unfortunate part of PAG oil. The same with ester oil too as well. So therefore, oil is constantly in motion, moving with refrigerant. So therefore, if you want oil to move, you got to have the refrigerant moving with it. So that's what's moving the oil with it. So that's why when you pull refrigerant out, it isn't surprising that it has oil with it, and that's what the machine is separating. So therefore, that is part of the recovery process. So therefore, if there's more than 2 to 3 ounces of oil, once recovery is complete, you may have too much oil in the system because as you can see here, people that buy refrigerants and they're trying to do their own charging, they're going to find out, like you see on the bottle on the right and the bottle on the left, you're going to see one has dye in it. So you might have a lot of dye in the system. Or B, you're going to see that it has oil in it. So therefore, as they add a can, they're adding oil, oil, oil. So therefore, they're over oiling the system, which in turn will affect the performance of the AC. It will not work properly. So therefore, please make note that most systems vary in oil, but 7 to 9 ounces on a single non-rear AC system is about the average that we see there. So therefore, that's what you got to keep in mind. So again, we're at the mercy of what have they done in the past with that AC system, whether they added too much oil or again they added too much dye to as well. So because there's some systems I've opened up the condenser and everything is coming out dye, dye, dye. I mean, they over dyed the system like you wouldn't believe. So therefore a lot of dye in it too as well. So here you could see a service manual specification. I did an '09 truck, an '0964 F350. Here you can see that it is recommending the proper PAG oil here. So as we look right here, we're going to see the PAG oil that's recommended here in the service. And it's going to tell you that the system capacity is how many ounces, including the compressor, okay, is 9 ounces. Thankfully, most compressors nowadays come with maybe an ounce. So therefore, it is still our habit when we take that AC compressor out of the box, whether it be in a reman or a new one, we also drain to see how much oil might come out of it to get an accurate count on how much oil there is. So therefore, the whole system itself, again, uses no more than 9 ounces, as you can see there. So therefore, definitely want to make a note of that, okay? Because there is specifications. And like I told you already, 6 to 9 ounces, somewhere around there, is the normal capacity of oil. So if you pull 3 out of it already, or 4 ounces, or 5 ounces, you pull a lot of oil out, that's telling you, wow, that was in the refrigerant alone. Some of it should stay in the evaporator, in the accumulator, the receiver dryer, or in the condenser itself. So if you're pulling out a lot of ounces already, chances are that that system is over oil, like I keep mentioning. So therefore, it is a wise idea to look up at the specifications. But from experience, I've learned on single AC systems, non-rear AC systems, they use about no more than 8 to 9 ounces. And that's kind of a telltale what you're supposed to do. So therefore, if you have an open system, let's say you have a seized compressor and you're replacing the compressor, I would hope you replace the orifice tube. In some cases, the expansion valve, and in most all cases, you should be replacing the dryer. You're going to drain that dryer to see how much oil comes out. So if I evacuated the system and I got 2 ounces, I pulled the compressor out and I saw that the old compressor had 2 ounces. That's 4 ounces already. And then I pulled the receiver dryer. I'm replacing the dryer too, or accumulator, and I pull another 3 ounces. That's already 5 ounces, or 6 ounces. So that tells you, yeah, this system is most likely contaminated. So, not contaminated, excuse me, over oiled. So therefore, we need to get some of that oil out and try to alleviate some of it because most systems, like we'll talk about later on in the final service of this, is we'll have 2 ounces in the condenser and about 2 ounces sitting in the evaporator. So do the math from that point. So I guess those are specifications. So as you continue your diagnosis, you're now going to perform a vacuum. So you recovered, right? You're doing a diagnosis, you do recover. The next thing a lot of guys will do now is we're going to put it in a vacuum. But in this case, why is there a vacuum, right? So in this case, what is a vacuum? Well, first of all, let's get one thing clear about pressures. I even did a YouTube video on my Diesel Talk YouTube page talking about pressures, gauge pressure versus absolute pressure. We're not going to get into that, but what I do want you to understand is how critical vacuum is. So I know that vacuum is supposed to, again, put the whole system into a negative pressure, but why? What are we trying to do? Well, so the question is, what is vacuum? Why vacuum? So for starters, vacuum is a low pressure. So therefore, when you look at a gauge, like you see this one right here that I just pulled off the internet right here, you're going to see that there's two different scales that we generally use to measure pressures nowadays. There's the kilopascal, and then there's your inches of mercury. So therefore, this is a dual purpose gauge, and you could see that there's 20 kilopascals right there. There's 80 kilopascals there. So therefore, they're saying that a perfect vacuum is 30 inches. Now, technically, reaching 30 inches is next to impossible, they say. We might get 28, 29. If you get 30, it's the total absence of high pressure. But let's just say you're getting a good vacuum, which is close to 25 to 30 to 29 inches. That is the equivalent of almost 100 or minus, excuse me, not minus, close to 100 kilopascals. So therefore, that is, again, you're seeing that you got 0, 20, 40, 60, 80, and minus 100 kilopascals. So therefore, pascals is a scale of measurement to measure both negative pressure, low pressure, and high pressure. Imagine I want to put carpet in the room. This is the example I always use. And I say, hey, I want you to lay carpet in this room, and I want you to measure the length in meters and the width in yards and tell me how much carpet I'm going to need. And you're going to like, yards, meters, that's two different scales or units of measurement. What do you want it? Do you want it in square yards or square meters? And in this case, we're using two different scales, right? No, I need to know either measure the length and the width in both yards or in meters, right? Or feet. I guess what I'm trying to say is we confused ourselves in this industry, whether checking boost pressures, whether checking vacuum, whether checking atmospheric pressure, with understanding that PSI, pounds per square inch, has always been a good indicator for positive pressures, while inches of mercury was used for negative pressures, right? Two different scales. So therefore, if I'm here in Las Vegas at 2,000 feet, the gauge pressure is not 14.7 at sea level. It's going to be lower because we're at a higher elevation. So to get started, vacuum is a low pressure. So anything under atmospheric pressure is a low pressure, whether being what's the vacuum. So therefore, okay, hold on a second. You're confusing me. Atmospheric pressure at sea level is 14.7 psi. So therefore, the gauge is going to read 0. So you'll notice this gauge right here is open to the atmospheric pressure down here. If you look right here, so therefore it's open to the air. So therefore it's reading 0. So what is 0 gauge pressure? It is whatever atmospheric pressure is. So those of you that are high altitudes, it's still going to read 0. If I put this gauge anywhere in the world at different altitudes, it's still going to read 0 gauge. 0 gauge is already inferring the atmospheric pressure where you're at. But then again, if I ask Siri on my cell phone and I say, hey, I need to know what the atmospheric pressure is today, it's going to vary because you might have a low pressure system of weather coming in or a high pressure system. Now, what am I trying to get at? What I'm trying to get at is when you actually look at a vacuum, you're looking at a negative pressure under atmospheric. So therefore, as I look at this gauge closely, I see that again, I go 5 inches, 10 inches, 15 inches, 20, 30 inches. I'm going to watch the vacuum pump just make a suction into that AC system. It's going to actually create a very low pressure under atmospheric wherever you're at. So when I look at an AC gauge, you got a lot going on in an AC gauge, okay? Depending what AC, and again, on the next webinar, we'll take a look at my gauges 2-in-1. We'll look at our machine 2 as well. But for starters, have you looked? And I challenge you to look. If you got separate gauges or you got one on your machine, it could vary. Okay. Some of them are just plain Jane numbers of PSI or inches of mercury. Some of them are like this one right here. Now, this one is giving me in Celsius, but you'll notice it works with various different refrigerants. Take a look at this. 134A, R22, R404A. So therefore, when we look at the low pressure gauge, now how do I know this is a low pressure gauge? Because it's blue in color, as you can see on the outside. Not to mention, I see the blue here. Now I'm going to throw this at you, and then we'll go over it more in depth. When I look at a low pressure gauge, I'm looking also at the temperature of the evaporator. Okay, that's on the low pressure side. So therefore, I can know what the temperature is. So therefore, let's say you're reading roughly 30 psi right there, right? So therefore, what is the temperature? You know, so in this case, you're trying to get an accurate of where the temperature is at. So in this case, we're going to analyze that even more closely where the temperatures are at. But in this case, you can interpret that. Now, this is in Celsius, okay? So therefore, this is in Celsius. So 0 degrees Celsius is 32 degrees. So therefore, obviously, this is greater than 32 degrees. So more like 36, 38 degrees Fahrenheit. But in this case, what I'm trying to say is that we can use the gauge not only to read the pressure, but also to interpret what the evaporator temperature is. Let me give you an example. So I just told you that at 30 psi, roughly we're about 36, 38 degrees, which is above 0 degrees Celsius Fahrenheit right here. So at that point, I can go ahead and measure my temperature of the inlet or outlet of the evaporator if I got access to see if it comes close to that. And then I'm going to have the temperature probe in the center duct to see what the temperature is. And that'll tell you the temperature that you're losing. In other words, the cold that you're using between the evaporator and the actual whole HVAC system until it finally reaches your face. For example, on motorhomes, when I work on motorhomes have these big dashes, right? So the evaporator sits in the front, right? And in this case, that whole dash of that big motorhome is actually very hot. So as the cold air goes out of the evaporator and finally goes to the face, it is cooling down all that plastic housing and duct work till finally it reaches my face. So therefore, I might have 36 degrees at the evaporator based on the gauge reading, but then at my face, I might have maybe 48 degrees. So as the engine runs, it's cooling down the HVAC housing. What should happen? It should actually cool down further because now all that plastic housing underneath that dash is now cooled down. So it kind of tells you how much loss of coolness you're losing just on the dash alone. So for now, though, all I'm trying to tell you right now is you ought to take a look closer at your gauge if you have this kind of setup to know what's going on. So here we can see I try to get a clear one, but this one will do. But this one's not in Celsius, but in what? This one's in Fahrenheit. So therefore, once again, if I go to 30, once again, you could see here, I'm going to try to go directly across. If the needle's going across, we're roughly how many degrees, as you can see right here. We're around 35, 34 degrees, somewhere around there. So therefore, that's what the gauge can interpret you. So saying again, I'm saying this again, is the low pressure gauge is telling you what the temperature of that evaporator is what's going on with that evaporator, based on the fact that the high side's working correctly too as well. I should mention that. Now, so therefore, again, you could see the similarities of this gauge, or you could see the scale for 134A, and obviously there's one for 22, but we're not using that. But in this case, you also can see that we're at 0 pressure, and then you could see your vacuum right here all the way to 30 inches. So therefore, you guys have seen this on many common gauges out there. So now again, this is a PSI gauge, so therefore we do read PSI, but we can also read Watt as well. So therefore, this is inches of mercury. There's your PSI, not very clear. And therefore, do we read kilopascals too as well? No, this one does not read kilopascals, as you can see here. So different gauges. So therefore, you can see the difference between one and the other as you look at the gauges themselves. So, but let's stick with vacuum for now. So we saw that vacuum, we measured it in inches of mercury or kilopascals, and I mentioned already that sea level pressure is 14.7 psi. Again, it can vary depending where you're at. So the higher altitude, the lower the pressure. Okay, and if you haven't understood that, I highly recommend do a Google search on it, because let me tell you, when I was searching stuff, I found a lot of cool stuff about pressures, and it was pretty cool regarding that, especially at a vacuum. So therefore, please note, if I'm at sea level, let's say I'm in, I'm at a sea level area, and in this case, if I'm at 14.7 psi on a good day, therefore I understand that anything under 14.7 is considered a vacuum. So therefore, we're creating a low pressure. So if I were to ask you, hey, what's a low pressure? The answer should be anything under atmospheric pressure. So therefore, but the thing is where it gets confusing is that PSI is for atmospheric pressure and higher. Inches of mercury is used for low pressures. And that's where it gets confusing. Two different scales, like I said, for measuring pressures. That's why the kilopascal is ideal, because kilopascal measures both high and what? Low pressures as well. So instead of using PSI and using inches of mercury, it gets confusing. So if I were to ask you once again, what is a low pressure? Where do we start measuring inches of mercury? Is anything under atmospheric? So if you're at, in Denver, Colorado, Denver's used all the time because they sit a mile high. In other words, 5,280 feet of elevation. It's 12 psi. That's their atmospheric pressure on a good day. There's no high pressure system moving through there. So therefore, anything under 12 psi for them is a vacuum. So you're doing a vacuum of an AC system, as you can see in this picture here. I still have my vacuum pump that I still use to the day, and in this case, got to maintain the vacuum pumps. And we'll get to how to test those vacuum pumps here in a bit. But you're putting it into a vacuum, and as you can see on this chart alone, what is the vacuum doing? In other words, it's sucking. A lot of people will say it's sucking out, right? So therefore, we're pulling a vacuum, we're sucking out the air. Yeah, but what you're doing is creating a low pressure. So you're pulling out that high pressure. So therefore, at the same time, you're doing that. But in this case, what are you doing to the air, right? So in this case, what are you doing to the air? You're actually what? You're actually changing the boiling point of water. So therefore, we're not sucking the moisture out. We are boiling the water out. Some of you may know this already. Some of you may not. So in this case, you got to understand what's going on in there. We actually need to make sure that we're boiling the water out. So just because the gauge moves down to close to 29, 30 inches, and you're pulling a vacuum, that still don't guarantee you have enough suction or volume to bring that boiling point down. So how many of you knew, let's see if you can type it in the chat, knew that you actually boil the water out? Let's see if how many know. Hit the chat and let me know. Did you know that you're boiling the water out? Type it in on the chat. I don't ask too many questions. I don't want to put you on the spot, but we're just asking. Anybody? Oh, come on. Don't be shy. Yes, no? Now, the reason why I'm asking is I'm waiting for some of you to reply, since some of you are not quick to reply. Let me go ahead and turn this off. What we're trying to show you here is, oh, come on. Let's go back to I'm trying to hit my link here. Sorry. And now we're good. Okay, so therefore, so you can understand, there's this YouTube video that I found, and I generally don't show too many YouTube videos, but in this case, let me go ahead and change my share window here, and it should be popping up here on my edge. And come on, close up. There you go. And this guy is describing, and I hopefully, and let me know, can you all see the screen there for the YouTube? I hope you can see that. It should be popping out. Yes, no? Again, I need your reply back here, so therefore, oh, that's showing a commercial. Let me just, I actually have to change this. Skip the ad. All right, here we go. Oh my God, we're running two of them. Hold on, hold on. Hold on, we're showing two. We got two of them running, and I'm trying to move them. Just a second. Let me just close that. Okay, there you go. Sorry, it went crazy there. So, all right, we're back up again here. So it just went buck wild on me here. So, oh, I closed it all. Okay, so it's all closed. All right. So what we're trying to show you is that, I can't tell you. So what I'm getting at is I'm actually showing here the actual what's going on with moisture in the system. So we're going to reopen this again. And in this case, what I'm trying to show you once again is that we're boiling the water out. Okay, so since we're boiling the water out, what I did years ago is I actually did my own tester too. So what I did is, and you're welcome to do the same here as I move slides. Let me just skip to the slide here. What I did is we actually have a mason jar, and I went to the local auto parts store and we bought a low pressure fitting. And at that point, we drilled a hole on top of the mason jar and we actually JB welded the low pressure fitting. Okay. So again, you J weld, yes, a low pressure fitting. And what we did is we filled the jar half with water and we filled it half with water. And at that point, what we did is we tested. I went to various different shops and say, hey, can I look at your AC recovery machine? I connected the low pressure fitting and only the low pressure fitting and put the recovery machine in a vacuum. Guess what? Half of the machines, and not more than half the machines, were not boiling the water in the actual jar. So what's it doing in the AC system? Not a damn thing. A lot of these machines don't get maintenance from different shops. They don't change the oil on the vacuum pump. So therefore, the cure to fix many was to change the oil in the vacuum pump. So a few shops said, hey, you're here, Tony. Why don't you go ahead and we'll change the oil. We'll go ahead and test it again. And many were now boiling the water in the jar after, changing the oil in the vacuum pump. So therefore, a lot of guys don't do that. So in this case, you need to verify. So a quick thing again you can do is buy a mason jar, get a low pressure fitting, drill a hole in the center of the cap, and go ahead and JB weld a low pressure fitting. And again, you can test the vacuum pump integrity because you want to make sure it boils water. If it don't boil in the jar, guess what? It ain't doing a damn thing. Now don't sit there and boil the water for a long time because you're going to contaminate the oil in the vacuum pump. It is a wise idea to still change the vacuum pump oil at that point once you've done the test. So therefore, please be aware that you actually need to make sure that it does boil the water because like I said already, numerous vacuum pumps and recovery machines that I tested while I was out in the field visiting shops, they weren't doing a damn thing. They weren't boiling the water in the jar, which again means that they're not actually bringing out any moisture out of AC systems. So therefore, again, vacuum pump is very important to understand there. So let me try to get this video working once again, see if it does work. Once again, we're going to copy this. Hopefully it'll work and won't show stupid commercials. Now we'll try it on the next session. It's not supposed to show commercials, but can be boiling there. So let me full size this. Hopefully it does work. There goes the commercial, sorry, but and we're trying to full size it. Sorry about the commercial. I was trying to do a commercial free on my account. So, all right. So what this guy's doing is he's going to boil water here. So here we go. Let's skip the commercials. There we go. So okay, so the video's not showing. Let me put it out this way then. This should work. Okay, let's try this again. You should be seeing the video now. Let me know if you can see it now. All right, for some odd reason, I am having bad luck here. The screen is actually not actually going to full throw. So let me stop the share here. My apologies. I did run a test on it before I even started. So let me go back to my presentation here. And what we're trying to illustrate there, if not, I'll send you the link. See, there it is working. Hold on. Let me try this again. Just a second. Let me copy this. I can fix this. Give me a second here. And let me go back. And let me go over here. So in essence, what he's trying to show you, and I'll fast forward when I open it up in this window. So this will be much better. Give me a second. I know how to fix this if my computer hurries up. All right, so let me go full screen on this puppy. It is important to understand what is going on. That's why really I'm reiterating this. Come on, full size. Everything is moving slowly as I'm moving different applications here. So really, why does it do that? Let me close this out again. Why is it doing this when I'm doing this? Close it. If you have any questions while I'm doing this, please ask. But again, what we're just, again, reiterating, I can't say enough about this, and that's why it's important about the fact that we got to make sure that the vacuum pump is pulling moisture. Because once again, when I see premature failure of AC systems, let's say they're going through a compressor every a year, 2 years, a lot of it has to do with how contaminated the system is. So, okay, so full size. Okay, now I got it. Now let me change the share, and I'm going to fast forward to get to that point. So, okay, now we're showing it. Okay, here he is. Okay, since you can't hear the sound, what you're going to see here, he's putting it into a vacuum, right? So the vacuum is continue to increase, right? You'll notice the temperature remains a constant right here. So he's watching in Celsius, 29 degrees Celsius here. So in this case, we see 29 degrees Celsius there. Again, he's pulling a vacuum. There's the water. The temperature is not changing, okay? So as he continues, let me mute it since you guys can't hear the sound. But in this case, as you continue to actually raise the vacuum, hopefully you can see the vacuum gauge going up on the far right of the screen. You're going to see the bubbles of the air that's already inside of the water start to actually, this, in other words, be removed there. I forget the word that they use. So in this case, again, you'll notice there's the bubbles. That is not boiling yet. That is just the air that's actually coming out of the water because as you know, like fish, they breathe the air in the water. So therefore, that's what's actually being dissipated. It's not boiling yet. So at this point, as you continue to build a vacuum, what is happening there? Well, what's happening at that point is that eventually we're going to start to see the boil. Again, the oxygen is the first that's actually being removed from the water. That's oxygen. You see the bubbles coming up. And then finally, you're going to see the boiling taking effect. Okay. Again, you see the vacuum. We're at about 28 inches there, roughly 29 close. So in this case, you're going to see finally the boiling taking place. So therefore it continues on, and then we finally see the boiling taking place there. That's what you see going on into the jar. So therefore, hopefully that kind of gives you a visual understanding of what's taking place with vacuum. But like I said already, the problem is that we see many guys that are thinking their vacuum pump is doing the job, but it's not. So again, my challenge to you is to go ahead and you know get a jar, mason jar. Like I said, buy a low pressure fitting, drill a hole in the low pressure fitting, JB weld that low pressure fitting and test, fill the jar up halfway with water. And at that point, you can see if it boils the water. Because if it doesn't, that means they ain't doing squat in that truck at all. So that means all these AC services you might have done with the vacuum pump, it could indicate that it hasn't done anything. So definitely something you ought to check. And like I said already, you're gonna have to take my word for it. It's up to you. But all I'm saying is in the past, when I visited shops with my jar, I gotta go find mine. But in this case, it doesn't boil the water at all, which means that we're not pulling any moisture. And those of you guys that are in very high humidity environments, that's something you got to understand there. So here you can see another example of another thing that I saw here is that, we see that the boiling point of water changes according to pressure. So if you're at a high altitude, like the middle picture right there, you're going to see that the pressure is 4.9 at this altitude, so in this case, the boiling point will change because that you're at a higher altitude, less than 4.9 psi. That's very high altitude, actually. So in this case, then you could see that the boiling point does change. So I guess pressure on the water will actually vary its boiling point. So at atmospheric pressure, we know that water boils at 212 degrees, right? But in this case, the temperature will change, the pressure will change, and in this case, that'll change the boiling point of water. So if you understand, what's going on with, pressures, you know that you can boil water easily when you take it down into a vacuum. So therefore, that's what you're going to find out there. So word to the wise. So hopefully you got that visual off the video. Sorry, I had issues with it, but in this case, like I said, the jar will work with you. So therefore, in conclusion with vacuum, you are using the vacuum to boil the moisture out. Not all vacuum pumps are boiling the moisture out, so you may need to change the oil of the vacuum pump. Definitely do some serious maintenance on that. Now, my machine, my old Robin Air machine that I have, that actually tells me, every so many services that I need to change the oil in the vacuum. Actually, I'm due for one right now. So therefore, it's a good machine to tell me when the maintenance is due for it. Yours might have the same thing too as well. And remember, air is dropped to a low pressure. So therefore, we're pulling out that high pressure out, in this case, creating a low pressure under atmospheric. So therefore, you're sucking it out, the refrigerant as well. And ambient temperatures, such as cold weather, can affect the charge rate as well when you charge that AC system, because again, cold weather also does not help in charging because the pressures might be too low as well, which we'll get into later on. But hopefully you can understand that when you take your system into a vacuum, you understand that, hey, I need to make sure that it is boiling the water. I am sure that I'm getting 28, 29 inches, maybe 30, but in this case, you're making sure that you're getting that vacuum, and it is indeed. So I guess what I'm trying to say, if you didn't understand nothing, what I just spent the last 10, 15 minutes talking about is it possible that you can have a gauge going down to 28, 29 inches, yet it doesn't boil the water? Yep. So therefore, you need, again, do your own tester to make sure it does work. So in the old days, and I'm sure they still sell those machines, there were some vacuum testing machines that you could connect your vacuum pump to, and it checks to see if it actually is pulling enough vacuum to boil the water out. But again, the jar method works very well. So therefore, you're welcome to do that too as well. So in conclusion with the AC service, once vacuum is performed, check for a drop in vacuum. Make sure you're doing that. You're verifying possible leak. So therefore, let's say you're done with the vacuum event. Let's say you did 15 minutes of vacuum. And at that point, you're going to check to see if the gauge moves. So if immediately it starts going back up, yeah, you do have a leak. You're not holding vacuum at all. You should hold steady to make sure there's no leaks at all. So therefore, you can do that. So remember, charge is weight. So at that point, you need to know what the specified charge amount. So here's two different trucks. The top one is a Power Stroke 6.4. The bottom one is a Duramax. And you can see that the Duramax on a L5P, yeah, it's an early L5P, is refrigerant capacity is 21 ounces, while the Power Stroke is 27 ounces, so therefore you should know the spec. I know there's a sticker that might be underneath the hood. You can look for that sticker, but in this case, this is telling you the ounces, which you need to move over to pounds, obviously, because most machine will ask you how many pounds and ounces it takes. So therefore, you can do the same as well. So therefore, there's an example right there. Here you can see I managed to find a Toyota one. I couldn't find a good 1234YF sticker. I got my Jeep too. I could have taken a picture of that. But in this case, the 1234YF is 470 plus or minus 30 grams, while this Ram Dodge on the bottom is a 134A, 595 grams, which is equivalent of 1.31 pounds. So in this case, you can do the translation. If you have a phone or you have some type of smartphone, you can have it do the translation or the conversion from grams to pounds. So therefore, it definitely works very well. So it is essential that you charge it to the correct weight and let the machine weigh it in for you to do it properly. So like I said already, when you started the AC service, don't judge the AC system by how it is. It's a good idea to evacuate it and recharge it properly just to make sure it has the correct charge in it. That's why we charge for that AC service. And like I said, you got to watch out there's no excessive dye, no excessive oil. And at the same time, you're also going to make sure it doesn't have a whole heck of a lot of air in the system. Because have I done AC services on vehicles I came in for not enough cool air? It was lukewarm and I just recovered and recharged, make sure everything's okay, and all. Now the AC system works great. Yeah, believe it or not, that has been happening. So therefore, you can come across the same thing too, because the person might have over oiled the system or overcharged the system, and that could have happened too. So as we move along here, we got less than 10 minutes left here. Um, Please note, humidity does play a role. I did mention that the AC system cleans, cools, and dries air. Here's a chart that is available just to give you an idea, is that when you judge an AC system, because I got some customers that have that temperature probe stuck in their duct on the center, and they monitor their AC performance there. They drive around year round with it in it. And the problem they're saying is, well, it doesn't get as cold on certain days, and it could be monsoon season for us here, where it's very humid. We get 60% humidity. And in this case, it's going to tell you right here, as you look closely, ambient air temperature, relative humidity, low side pressures, high side pressures, and your maximum center temperature. So let's look at a humidity level of, they're saying 0 to 100% humidity, low side, high side, but in this case, greater or low or less than, below 35%, 35 to 55%. What do we see the temperature start to do here? So, oops, the temperatures will start to what? Rise. Here we can see 50 degrees, and in this case, above 50% humidity, we see the temperature go up to 66 degrees and keep going all the way, even up to 70. 70 degrees is normal at a very high humid condition. So I guess what I'm trying to say here, based on this chart, is the higher the humidity, the higher the duct temperatures. Because the people are still going to feel cool because that dry air is drying the moisture on their face and they're going to feel the cold from it. So in this case, that's what happens. And if you don't understand that, always remember if it's very humid and you put alcohol in your hands, the alcohol absorbs the moisture and you feel cold. So therefore, when people feel the dry air, cold, dry air across their face, that humid air, that humidity that's on their face, the moisture on their face is going to actually be dry and they're going to feel cool with that. So therefore, they're like, hey, Tony, how can I have 70 degrees and yet still be cool when I'm supposed to be down in the 46, 43 degrees? Because again, the humidity factor. So it is normal to see warmer temperatures in a way when it's very humid because again, the system is working harder to dry that air. It's trying to extract all that moisture out of the air as it's going across the evaporator. So therefore, it's going to freeze it up a little bit on there. So therefore, that's what we see going on. So again, once again, more humid, the higher the temperatures you're going to see. But again, the customer will still feel cool because it needs to shoot that air across the face that makes them feel dry. Now there are pressure temperature charts out there. In this case, you understand or you can do that. Just even this is a quick test you can do as well to test the contamination of a tank. For example, I understand that at 65 degrees, 65 degrees, the low side pressures ideally should be again 25 to 35 at 65 degrees of ambient temperature. Let's take it more realistic. Let's say 100 degrees. So at 100 degrees, low side pressures could be 50 to 55. Now, I can disagree with this, and let me tell you why. Because A, humidity is a factor, and B, if I got excellent airflow going across that condenser, I'm going to get colder. So therefore, these pressures will be lower. I'm not surprised that I will see 35 to 45 psi. It can get colder. So these would be, to me, high numbers for that given temperature. But again, you cannot straight judge this for the simple fact that these are ranges only, by the way. These are ranges only for the simple fact that humidity and the amount of airflow across the evaporator is going to vary this. Let's say the truck is idling. I'm watching 45, 50 psi on the low side, right? All of a sudden the fans start to roar. More airflow, more cooling, the pressures are going to drop. And in this case, it might drop as it's idling. It might drop to, let's say, under 45 psi. And that's what I could see there. There you could see your high side pressures too as well for a given temperature. So in this case, 275, excuse me, 315 to 325 is about normal what we see there. So you're going to be around these ranges. So these are not accurate numbers. But I will demonstrate something here. As you look at 134A, let's use the 100 degrees, okay? 100 degrees, 50 to 55, 315 to 25. Compare that with 1234YF. When you look at 1234YF, 100 degrees, 50 to 55. What did we have for 134? 100 degrees, 50 to 55. So the pressures are pretty much identical with 1234YF. Why am I saying this? Because a lot of people are saying that 1234YF, the pressures run higher, and that's not the case here. Let's look at the high side. Still at 100 degrees ambient. High side, 315 to 325. If I go back to the 134A, 315 to 325. So therefore, believe it or not, that 1234YF and the 134A are pretty damn close to being almost the same. Not exactly, but pretty close to being the exact same pressures. So your temperature pressure charts are almost the same between 1234YF. Now let's take it up to 110 degrees. 50 to 55, 110 degrees, 50 to 55, as you can see there on the low side. And on the high side, 340 to 345. And what do I see right here? 340 to 345. So therefore, the pressures on the temperature pressure relationship charts are pretty damn close. So therefore, that's what we see going on there. Make sense? So therefore, that's why off the record, I should say, is I'm hearing of a lot of people that don't want to deal with the 1234YF. They're converting them back to 134A. I know people doing that. And you're not supposed to. You're supposed to keep the gas, but you can get away with it because the pressures are the same. The question is the compressor and the dryer probably need to be changed. I'm not sure. I don't know, but I haven't tried it yet. But in this case, I know people taking 134YF to 134s back. So be aware of that. So, all righty. So therefore, that's what we're talking about there. What do you think? All right, some intros there when it comes to the AC systems you get there. So I guess I wanted to clear up that the 1234YF and the 134A, the pressure temperature relationships are very identical to each other. So there you go. All right. Dave is asking me, is there Q&A? So yeah, Dave, turn on your microphone or let's ask some questions. Any questions? That's what I do every time at the end of a presentation or throughout a presentation. Ask any questions you would like to ask. Hopefully that helped you a little bit. This is part one now, mind you. There's still a lot to talk about, but I wanted to get over the service and the gases themselves, which you need to look out for. So, and those of you watching the recording, you can email me questions. I know a lot of you are going to watch the recording. We only have a small crowd here today, but you can watch the recording there. So, questions, ask away. Any questions? Dave, you have any questions? You brought it up. I'm glad you did, my friend. Any group, you can type in the chat questions. Please ask. Again, you can unmute. I don't have nobody muted, so therefore you can turn on your microphone. Dave, do whatever you want there. Waiting on you. Waiting on you. No questions? Because we're just about time here. Any questions? Questions? Wait on questions. I'm going to stop the recording here and we'll continue on part two. But